Good day. I am Dan Nicole F. Aras from 12 Gotham. In completion for General Physics 1, I will be presenting my chosen lab at home experiment, which is the Newton's first law, first condition for equilibrium. The objectives are explain the condition for equilibrium of a point object, explain the connection of the different factors in the experiment and how it affects the overall result, and apply what has been learned in General Physics 1, particularly Newton's first law of motion. The materials used are the following: 3 pieces 25 centimeter strings, 20 pieces 1 peso coin, 1 piece of short-sized cotton bond, and a protractor. As seen, the setup in this lab at home experiment are 2 chairs and blocks of the same height, a pipe connecting those 2 chairs, the yarn, which is the string used, and the envelope that contains 20 coins. For the data and results, we have to first find the mass of the suspended object using all the information we know. So for the mass, we have the answer of 0.124 kilograms. From the answer acquired from the mass of the suspended object, we can now find its weight. Using the formula W is equal to m times g, we will arrive to the answer of 1.215 newtons. For the setup A trial 1, we have the FPD of the knot. In this trial, both the left and right are 30 degrees. Because of this angle, for the X component, we have the left tension cos 30 and right tension cos 30. As for the Y component, we have the left tension sine 30 and right tension sine 30. In this slide, we can also see the FPD of the suspended object and how the experimentation was done. For the setup A trial 2, we have the FPD of the knot. In this trial, both the left and right angles are 60 degrees. Because of this angle, for the X component, we have the left tension cos 60 and right tension cos 60. As for the Y component, we have the left tension sine 60 and right tension sine 60. Also in this slide, we can see the FPD of the suspended object and how the experimentation was done. For the setup B trial 1, we have the FPD of the knot. In this trial, the right angle is 70 degrees, while the left angle is 30 degrees. Because of this, for the X component, we have the left tension cos 30 and right tension cos 70. As for the Y component, we have the left tension sine 30 and right tension sine 70. In this slide, we can also see the FPD of the suspended object and how the experimentation was done. For the setup B trial 2, we have the FPD of the knot. In this trial, the right angle is 67 degrees, while the left angle is 32 degrees. Because of these angles, for the X component, we have the left tension cos 32 and right tension cos 67. As for the Y component, we have the left tension sine 32 and right tension sine 67. In this slide, we can also see the FPD of the suspended object and how the experimentation was done. Using all the data acquired, we can now solve for the tension, standard angle, XY components of the vertical, right, and left string. Furthermore, after solving all the data, we can now find the sum of the X and Y components. For setup A trial 1, the sum of the X and Y components is 0, which makes sense because the object is at equilibrium. For setup A trial 2, the sum of the X and Y components is also 0. For the setup B, the sum of the X component of trial 1 is 0, and the sum of its Y component is negative 0.0001 newtons. For setup A trial 2, its X component is also negative 0.0001 newtons and its Y component is negative 0.0002 newtons. If we increase the weight of the suspended object, the angles left and right will go up to 90 degrees angle because of its limited distance and because the object's weight is equal to its tension. As the weight increases, the tension also increases. From the experimentation, the factors present that may affect the results are the mass of the suspended object, meaning this is the number of coins in the envelope, the length of the yarn on both sides, and the way the yarn was tied to the stick or pole. In the experiment, all sums are equal or approximately zero, and these data show that the object is in equilibrium. Thus, the left pull of the string balances its right pull. There were no changes in my experimental result compared to the theoretical results, since the experiment was properly executed and all answers resulted in zero or approximately zero, meaning the suspended objects was in equilibrium. Nevertheless, the factors were overcome because the experiment was executed properly, the guidelines and procedure were followed, and the formula and free body diagram were used to measure all data, and the result in each setup was correctly distinguished. For an object to be in equilibrium, the sum of all its external forces acting on the body must be zero. In this experiment, the object is a point on the string, which is the envelope containing the coins. It is in equilibrium since all the sum of the x and y components in both setups and all trials are equal or approximately zero. Therefore, I can conclude that the suspended object at rest is in equilibrium. Furthermore, different factors such as the weight of the object and the length of the strings affect the process, but not the overall sum of an object in equilibrium. It is where Newton's first law of motion can be applied, since through utilizing the equation, one could identify that the weight would also be equal to the tension, which could overall affect the equation. Also, as one decreases the length of the string, its angle would increase, being closer to the center. The situation happens since its movement would be limited. Thus, it affects the process. However, for both factors, since the object is in equilibrium, its overall sum would still be zero. And that ends my presentation for today. Thank you.